Okay, here we are filming the answer key for the practice test on transformations. Identify the parent function for this guy. This is clearly an absolute value. You can just write f of x equals absolute value of x like that. That's fine. You can write the words if you want. Critical thing is that you know what the parent function does. It's good to sort of sketch that graph. It's a 45-degree line that goes zooming off that way and one that goes off this way. The slope is 1, but we're messing with this. We've moved it to 4, -2, so it's going to be absolute value of x minus 4, and there's going to be some stretch factor vertically. It looks like it's been stretched because it's not going over 1 square, up 1 square. And I'm just going to put a out there, and then it's going to be -2 for the vertical shift downwards. And I happen to know that this other point 2, 3 is on it, so I know that I'll get 3 out when I plug 2 in. I don't know what a is, and then it's 2 minus 4 minus 2. So I do the math. 3 equals a, and then the absolute value of -2 minus 2. So 3 equals 2a when I take the absolute value, of course. So then that gives me 5 equals 2a, and a equals 5 halves. I've seen you guys make that mistake. You're dividing both sides by 2. So the final version is 5 halves, then x minus 4 in the absolute value minus 2. All right, so that's your final answer. Name the parent function for this. That's exponential, and you can of course write 10 to the x as sort of the basic function that's going on there. Again, if you start with the sort of parent function, exponentials go zooming along, really hugging that until they go up to 1, and then they really take a left turn and go all the way up here to the point 1, 10. Just think about what it means to plug in a 1 there. You're going to get 10. Plug in a 0, and you always are going to get 1. 10 to the 0 is 1. So know those 2 points. What's happening to it? That negative sign up there flips it, so it's the mirror image. And then this 1/5 squashes everything down by a factor of 5, so that 10 is cut into 10/5 or 2, and this 1 is cut into 1/5. So the final graph then, after I shift it, the whole thing, I do this math first and then I shift it down 3, is going to take this horizontal asymptote and move it down to y equals -3, and this is going to be squashed down to 1/5, and then move it down to 1/5 above -3, going like this. And then when it's flipped over here, that's going to be -110, and then shifted down 1/5 of the way to the y-axis would be +2, and then when that's shifted down 3 units, it's right there at -1, -1. All right, and it's going to curve up like this. I don't know if I should label everything. I think you guys, when you do it, should just do it in pencil and label things carefully. That is -1, -1. Okay. All right, so then, oh, I guess I didn't need to put that in there because I'm just graphing. But if you want to recopy it, I suppose you could. All right, so name the parent function here. This is a cubic, okay, so the original goes to the origin, it goes through 1, 1, and then -1, -1, so it's kind of just going up like that, turning and going up. It's one of those odd functions we talked about. What's happening to it is being shifted 2 to the right and down 1, and then squashed by a half this time. So you move it, did I say 2 to the right? Careful. 2 to the left because it's going to be equal to 0 when x equals -2. So I move this 2 to the left and then down 1 right there. That's that point. And then I'm going to go over 1 and up 1/2 and back 1 and down 1/2. And that is my curve right there and my other reference points. So right there is -2, -1, and another point here is -1, and then -1/2, because I've gone down just 1/2 from the 0 line. All right. Then a function is defined by some random f of x that produces some shape, and we have like a belly button point, 0, 0. Describe in detail what will happen. Well, it's going to be shifted to the left, shift to the right, shift right 1 unit. Again, it's the opposite. When is that equal to 0? It's when it's +1. So you shift it to the right 1 unit, and this is going to move it, shift up 3 units. And then this one, it's getting complicated. I'll do it over here. Is going to flip over, and then that's changing. Every y value is going to go from plus to negative, and every negative y value go from negative to positive. So it's flipping over x-axis, and then vertical stretch by a factor of 2. Twice as big away from the x-axis. All right. These guys hopefully are a little bit more straightforward. We're taking this triangle, and if you want to, it says describe the effect of following matrices, that's this matrix, on the position of this triangle when multiplied by the triangle's matrix. Sketch the transformed triangle's new position. If I'm going to multiply this times a matrix, what is that? Well, that looks like it's -5, and then up 1, and then -5, and up 2, and -1, and up 1. And if I multiply it, you'll see I take and flip this so that it's 0, 0, and 1. And then that 0 is going to ignore any of these values, and only the 1 will copy all these numbers. But since that's the top, it'll then move it into the top. So it goes 1, 2, 1 in the top. And then the negative copies the top number but switches their sign, so it becomes 5, 5, 1. So if I graph that and I go over 1, up 5, and then over 2, up 5, and then over 1, up 1, you'll see that it's now gone like this. So this is a 90-degree clockwise rotation, and centered at origin. You really should be complete, all right? I know that if you don't say anything, it's kind of implied that it's centered at the origin, but if I trace this with paper, I've got to put my thumbtack here. If I put the thumbtack there, it would just spin in place, but I've got to rotate it up to there, 90 degrees. All right, so this one, same idea. If I take that -5, -5, -1, and 1, 2, 1, and I multiply it, it's going to take these top numbers and switch all of their signs and make them twice as big. So it's going to be 10, 10, and 2. And then it's going to take these bottom numbers and make them all twice as big, but not switch their sign. So 2, 4, 2. If I graph that, if I go over 10, 3, 4, 5, and up 2, over 10 and up 4, right there, and then over 2 and up 2, you'll see that it's gotten twice as big, but it's also flipped it over the x-axis. So it's like it expanded it away from the origin and then flipped it over. So flip over y-axis, dilation it's called, factor of 2. Alright, on to this one here. Again, same thing, -5, -5, -1, and 1, 2, 1. When I flip this and multiply that 1 and 0, it just copies the entire top row, does not change it. -5, -5, -1, This bottom takes these numbers and multiplies them by negative 1/2, so it's going to flip the sign, negative 1/2. That's going to be negative 1, and that's going to be negative 1/2. So if I go to graph that, it's going to be negative 5 and negative 1/2 down here, and it's going to be negative 5 and negative 1 and negative 1, negative 1/2. So it squished it and made it even skinnier, difficult to draw. There's my right angle, there'd be my right angle right there. So flip over, this is x-axis, and then a vertical scale or vertical stretch, if you want to call it that. It's not really stretching it if it's making it shorter, but I'll take that. Stretch, can't spell when I'm writing in a hurry, by factor of 2. All right. On to the last or third page here. What will be the effect on the position of the triangle if this is added? Well, when you're adding, and you'd think I would have all those coordinates down by now, negative 5, negative 5, negative 1, and I think it's 1, 2, 1. I do remember that. 1, 2, 1. If I just simply add that, you'll see that this is going to be negative 2 and negative 2 and then positive 2. And down here, when I add that, it's going to be negative 6 and then negative 5 and then negative 6. Now, I'm not actually going to graph that. You'll see it's just a translation. Over 3 horizontally, down 7. Okay? And you could write that in a little bit more detail than I am. All right, here we go. A little geometric golfer type problem. Given the position of the shaded right triangle with vertices shown in the matrix below, write the fewest number of matrices that will transform that. Okay, so what can I do? I can flip over water, but I can't flip over trees. All right, now if we're strictly going according to matrices, I would like to flip this over the water so it's not in the water. If I flip it right here, it'll become like halfway onto the water, and it really can't do that. So there's a bunch of ways to do this, but I think that probably I want to figure out how to get it right here, okay? And then I'm going to flip it over to get down there, all right? But I need to do a second half of this.